Hello, welcome. Today we have this beautiful, nice equation to solve. Square root of x plus 1 in bracket square divided by 6 equals to 5 minus square root of x divided by square root of x. We want to find the value of x. Right, very interesting equation. So let's look at solution. Alright, we are going to write this equation. We have x square root of x plus 1 squared over 6 equals to 5 minus square root of x over square root of x. Right, so now let's see what we're going to do here. We can write this one as this. We have square root of x plus 1 squared over 6. Now let's focus on this side. Here we have 5 minus root x. So if I add 1 here, if I minus 1 here and add 1 here, it's clear that I've not changed anything from the top. Similarly, from the down, if I have root x and I add 1 here and minus 1, I'll still not change anything. But this equation will now become root x plus 1 raised to the power 2 over 6 equals to 1 plus 5 will give us 6 minus. So now we want to treat this one as 1. So let's put this one in brackets. So minus outside, here we left with what? Root x plus 1 all over square root of x plus 1 in brackets minus 1. Right. So here we can see that we have x plus root x plus 1 here. We have root x plus 1 here, root x plus 1 here. So we can say let k equals to root x plus 1. Right. So if k equals to this implies that in this equation we can write this one as k squared over 6 equals to 6 minus, here the whole of this expression equals to k, here is equals to k, so we have here as what? K divided by k, which is this side, k. So we have here as what? K. We have k minus 1. We can do cross multiplication here. So the cross multiplication, we multiply this one to this and this one to by this. So here we have k squared brackets open k minus 1 equals to 6 brackets open 6 minus k bracket close. So let's open the brackets. K squared times k will give us k to the power 3 minus k squared times 1 will give us k squared equals to 6 times 6 will give us 36 minus 6 times k will give us 6k. Now here we rearrange the equation. So we have here as k to the power 3 minus k squared minus, so let's see here, the minus 6 across in that side will become plus 6k. 36 will become minus 36 equals to 0. So now we have k to the power 3 minus k squared plus 6k. Now let's split this one. 36 can be written as minus 27 minus 9 equals to 0. Right. So here we can arrange this equation further by taking k to the power 3. Now bring the minus 27 here, so we have minus 27 minus k squared plus 6k minus 9 equals to 0. We have rearranged the equation. But 27 is the same as 3 by 3 by 3, and that is equals to 3 to the power 3. So we can write this one as k to the power 3 minus 3 to the power 3 minus k squared plus 6k minus 9 equals to 0. So here, let's rewrite this equation in brackets. So we have we have k to the power 3 minus 3 to the power 3 brackets. Now here we bring minus outside. If the minus is out here, we have here as k squared. Here, when the minus is out here, we become minus what? 6k. And when the minus is here, we become plus 9 equals to 0. Let's look at this identity. If you have a to the power 3 minus b to the power 3, define as a minus b, brackets open, a squared minus plus ab plus b squared. Right. So applying that, we can have here as k minus 3 in brackets multiplied by k squared plus 3k plus 9. And then when you come to this part of the equation, this one, we can factorize this one too, as we are going to look for two numbers when you add. You see, the sum of these two numbers that can give you minus 6 and gives you a product of 9 is minus 3 minus 3. So this one is a perfect square number. So this one can be expressed as minus, brackets open, k minus 3, and here k minus 3, and that's equals to 0. Right. So here we can see that k minus 3 is common. So we can factorize that one out, and we have k minus 3, brackets open. Here we're left with k squared plus 3k plus 9. Now remember, this one is out, so we'll have left minus into brackets k minus 3. So minus against a k will give us minus k, and minus with the minus 3 will give us plus what? 3, and that is equals to 0. So here we have k minus 3 equals to, and multiplied by k squared plus 3k minus k will give us 2k plus 9 plus 3 will give us what? 12, and that is equals to 0. So we have here k minus 3 is equal to 0, or k squared plus 2k plus 12 equals to 0. So here k is equals to what? 3. So this is the first solution. Now to factorize this one, we need to test the discriminant first. So we have discriminant is equals to b squared minus 4ac. So here, from this equation, a is equals to the coefficient of k squared, which is 1. B is a coefficient of 2k, and that's going to give us 2. That's the k. And then the c is a constant, so c equals to 12. So here, the discriminant is equals to b squared, that will give us 2 squared, minus 4ac, that's 4 times a, which is 1, times c, which is 12. So we have here as 2 squared give us 4, minus 4 times 1 times 2 give us 48. So here we have 4 minus 48 to give us minus 44. So clearly our discriminant is less than 0. So there will not be real roots. So no real what? Roots. So we ignore that one. Then we come and concentrate on k. That is, concentrate on k equals to what? 3. Let's go up. Recall, we said k was equals to root x plus 1. So let's bring it down there. We have root x, k is equals to root x plus 1. But k is equals to 3 in this case. So this implies that 3 is equals to root x plus 1. So let's rewrite the equation as root x plus 1 equals to 3. Let's group like terms. We have root x equals to 3 minus 1. Then we have root x equals to 3 minus 1 give us 2. So we have root x squared equals to 2 squared. So here we have x, the square root to break this one, and we have x equals to 2 squared, which equals to what? 4. So therefore, the true set for this equation is x equals to 4. So let's go up here. We can say that x is equals to 4, and that is the solution set. If you enjoyed this video and still want to get more videos like this, please do well to subscribe so that anytime I make new videos, you get notification for that. Thank you for watching. See you next time. Bye bye.